in the AM. I'm recording this in the PM. It's 5.4, parallel lines and transversals. Okay, what are we going to work with? Well, if two parallel lines are intersected by a transversal, now I hope you know, parallel lines should not meet each other. A transversal intersects two lines. Okay. I'm just going to hide this here. Okay, a few things about this. Two parallel lines are intersected by a transversal. So let's just get this scenario set up. Two parallel lines and a transversal. And I'll see, as we read through this, do we understand the rules? You might want to draw on your paper and put those in. Alternate interior angles are equal. So when I say this rule, think of the Z. Alternate interior angles are equal. Those two angles would be equal. Likewise, the interior angles here and here are equal. That's what this first rule is about. Corresponding angles are equal. What do I mean by that? I mean, this angle here corresponds, is exactly the same as that angle there. Likewise, this angle here corresponds and is exactly the same as that angle. And I can do the same on the other side. I don't want this diagram to get too cluttered up, so I keep removing it. But this angle here corresponds to this angle here. And you can hopefully see that. They're equal. Interior angles on the same side of a transversal are supplementary. Huh? That means interior angles inside on the same side. Angle A and angle B here will add up to 180 degrees, supplementary. Okay? You got to know the word. Likewise, on the other side, angle C and D here, they add up to 180 degrees as well. Okay? So, as long as you know that given two lines cut by a transversal, alternate interior angles are equal, corresponding angles are equal, or interior angles on the same side are supplementary, then you know that the lines are parallel. You need one of these three rules, this one, or this one. One of these three facts has to be true. And then you can say that the lines are parallel, okay? Now, example one. Consider the diagram below. We know that these are parallel, L1 and L2. These guys are parallel. What are the measures of the three indicated angles, and explain how you reach your answers? Pause right down and see if you can try this yourself. Now, okay, if you started it up, let's go over the answers. If you didn't pause, really do pause and try this out. I'm not going to write out, I'm going to put the answers in there, but if you're listening, I'll explain how we reached answers, okay? Now, a few things to do here. Here's what I'm thinking. Angle 4, just darkening that. Do you see how angle 4 is corresponding to angle 1? So, angle 1 must also be 122. Why? Corresponding angles. I'm going to run out of time. Now, interior angles 1 and 3 must add up to 180. So if I know that, we're saying 180 is equal to angle 1 plus angle 3. And we know that angle 1 is 122 degrees. You guys have 9 minutes. Keep working. Other folks. So What are we going to do about that? Subtract it over. 180 minus 122, and you got 58 degrees. Angle 3 on the diagram. Now that I have angle 3 done, there's a number of ways to do things. You could say angle 3 and angle 2 are equal because they're vertically opposite. Opposite angles, that's probably the easiest way to do it. Angle 2 is equal to angle 3, they're opposites, 58 degrees. Okay, you need to write down your reasoning. I ran through the reasoning. That's not the only way to reason that one out. Now, example 2, I'm going to go over. You pause the video right now and try it. Okay. Start up the video. And if you haven't, I'm going over the answers. But identify all pairs of parallel lines. Explain the selection. Looking at this, I'm going to do it out loud. So line 6 and line 4. I'm taking a look at it. So which one's line 6, line 4? Now, how would I know line 6 and line 4? Well, what's the transversal, maybe? I could see a few different ways. The best way for line 6 and line 4 to be that, well, and I'll just, this is what I'm talking about here. Again, if I consider L1 as the transversal, L6, L4 are parallel. I'm going to use this symbol for parallel. Since 100 degrees, 80 degrees are supplementary. And that is using a transversal at L1, okay? That's the interior angles. Same side of transversal. Interior angles on the same side of the transversal. Make sure you get that down. Look back at your rules if you were sure what I said. What about L1 and L2? Hopefully you got those as parallel. So if I consider L1 and L2, sorry. How do I know that? Because 100 degrees corresponds here and here. The only way they could be corresponding and equal is if those two lines were parallel. This is the transversal we're using along that line. So L1 and L2 are parallel since L6 is the transversal and the two 100-degree angles are corresponding. Get that down. Then try example 3, pause right now and then start her up. Given, okay, let's go over this. Given parallelogram ABCD, that's this picture below, determine the values of angle A, or no, A is given, angle B, C, and D in that order. State a reason for each measure. Now, you can consider parallelogram is called a parallelogram because two sides are parallel. Consider this like a transversal. You have to do it in this order. So B, I say interior on the same side. Angle A is 130. Angle B must add to 180. It's supplementary. So angle B, same side, interior. So that's 180 minus 130. 180 because it's supplementary. That's going to give me my difference of 50 degrees for D. Now, there's other ways of doing this, but we have to use the, we got to use rules anyways, but we got to now find C. Guess what? C, you can consider BC, the line, as a transversal for these two parallel lines because it's a parallelogram. And if we just already knew that this is 50 degrees, then we know that it has to be supplementary. And angle C also has to add to 180 with that. So that's 130 again. Using the same argument, but with DC as the transversal for these two parallel lines, we know that this is supplementary. Angle D must be 50 degrees because 50 plus 130 at angle C add to 180. Now, you guys are going to try some of these problems here. Similar there. Take a look at these and remember, this is a 90 degree because it's got the little corner in there. You can work things out there. And parallel lines, the lines could be extended, meaning this could go all the way through here. What does that tell you? If it's necessary, this could go all the way through here. That's possible. And then look at this. Try these out and be ready for a quiz on 5.3 and 5.4. I'll give these marks. Good luck. Hi guys, yeah, you know.